Hi there, everybody. I am Kathy Zip, Managing Editor of Solar Power World magazine, and I'd like to welcome you to today's webinar, What You Need to Know About Selecting an Energy Storage System. And this webinar is just going to kind of give an overview of the different considerations you need to look at when choosing and installing an energy storage system. So before we begin, I'll just go over a few house cleaning items. A lot of people ask about if the webinar will be available after the presentation, and it will. It'll be on solarpowerworldonline.com, and it will also be emailed to all registrants. So you'll get an email again to view it at your convenience. And there'll also be a question and answer session at the end of the presentation. So we encourage you to participate in that. You can submit your questions at any time during the presentation. Just type them into your Q&A box. And we invite you to tweet along with us at #SolarWebinar. And at this time, I will go ahead and introduce our presenter. We would like to welcome Brian Witten, Product Manager at Darfon America. And Brian brings more than 20 years of experience in the electronic and solar industries. He actually ran his own solar company, installation company, before joining Darfon 3 years ago. And as a product manager, Brian helped define and bring to the market Darfon solar products like the G320 microinverter and the AC rack, and as well as other solar energy storage and green energy products. And I've known Brian for years, and I love that he brings his solar installation experience to this conversation. So he definitely knows his stuff, and we're very glad to have him here with us. So Brian, go ahead whenever you're ready.
Okay, thank you very much, Kathy. I appreciate that. Didn't know I was that good. Okay, so today we're going to be discussing what you need to know in selecting an energy storage system. The market for the energy storage technology is really changing rather rapidly. It used to be off-grid, a little bit of backup type stuff, and that's what was available. And it was designed specifically for that kind of purpose. There was no heavy technology involved in it. It was complex, expensive to install. You had all these big lead-acid batteries that you were constantly working with to check the water levels and the specific gravity of it. You wound up having to design the system as kind of a putting together the pieces, because there was no one place to go typically that could do it all with just a simple plug-and-play type approach. So that's where we're at now. Where are we going? We're moving on with the advancement of the storage system. Why is it advancing? There's a lot of reasons driving this. First and foremost, the threat of grid destabilization. As many of you know, particularly those that may have been in or servicing the Hawaiian market, the installation of solar is very close to the limit of destabilizing the grid, because the built-in grid, the utility, can't maintain proper voltages and frequency because all the solar fed in. So there's now new requirements. You've got self-consumption. That is, whatever PV you put on, you've got to use the power. You can't pass it forward to the grid. Here in many states in the West, we've got net metering being abandoned, making it financially unviable to put solar on a house. So again, you're stuck figuring out how to use the power if you want to do it. And then also new time of use schedules that are less compatible with PV production. Most PV systems generate power through the middle of the day, tapering off at the end, building up in the morning. That used to be really good because it helped the peak time of use in the middle of the day when the air conditioning was running and people were at work and so on and so forth. That's now changed with their peak because of the solar production being moved into the evening, because that's when people get home and start off their air conditioning there, start off their food preparation, so on and so forth. So they're changing time of use peak. Another reason that some of the demands are changing is our lifestyles have become much more dependent on electricity. It's very difficult to survive when the electricity drops out. You see this a lot in the news in the wintertime with weather going in the New England area or down in the southeast where you get nasty hurricanes. weather that causes problems. In the Midwest, snowstorms that cause major outages. In the Rockies, you get wind and snow that can cause problems. So pretty much everywhere you go throughout the United States, there's some natural disaster of some kind that can cause electricity to drop out for extended periods of time. So people are saying, we need more than solar. We need to be able to continue using it. And then there's that growing desire for customers to simply go off-grid. This is something that some people just want to do, and so the technology to support the rest of this is moving ahead with the ability to actually do that shortly or in the near-term future. So the current technology for embedded systems, that is what we're working on right now, is utilizing something called a hybrid inverter. This combines the functionality of your PV inverter, your grid tie, your battery control functions, all together in a single cost-effective system. So you've got a bidirectional inverter, one that goes from your batteries to utility, one goes from PV to utility, one that controls PV to batteries. All of that can be dealt with, and in addition to that, from batteries and or PV to whatever your critical path loads are. So a hybrid inverter handles all of that in a simple, single, integrated package. Along with that, we've got much higher density batteries. You see a lot of different technology now, whether it's lithium ion, advanced lead acid, lithium iron phosphate. All of these have much greater life than the old lead acid flooded batteries did. They have a much greater depth of discharge in many cases, less heavy, less maintenance. They oftentimes don't need any support ongoing at all. We've got grid support, so hybrid inverters need to be able to support the new time of use, support lack of being able to feed in, manage the power that you've got, whether it's PV, whether it's batteries, wherever the source is coming from. It needs to look at the loads, the demands that you need, and then satisfy the best way to do it. Sometimes that's forced on you by grid outages. Sometimes that's forced on you by cost of electricity. Sometimes it's cheaper to go at this time than that time from the batteries. And your hybrid inverter should be able to deal with that, thus the intelligent power use. It's really a much more sophisticated program than just being off-grid and handling all the power needs. You really do need to take an intelligent approach to how you're going to manage your power. So let's look at the components of a new ESS. We've got the hybrid inverter. So if you look at this, you've got your PV coming in. That comes into the inverter, satisfying the needs for the battery, satisfying the needs for the grid, and your load. You've got the battery coming in. So again, going through the inverter from the battery to the grid to your load, whatever it is that your particular system needs at that time. Going the other way, you've got your battery management system. So this is your charge controller. For those of you that have installed systems before, this can kind of replace that part of it. So it manages the batteries. If you've got a lithium chemistry battery, you've got a very sophisticated battery management system that takes into account temperature, takes into account state of discharge, takes into account where you're going to be charging from, what the voltages are that you need to maintain, what kind of battery system you have. Is it lithium phosphate? Is it lithium iron phosphate? Is it lithium ion? Is it any of several other types? It's got to support lead acid if that's what's attached to it. All of these things need to be supported in a comprehensive battery management system and hybrid installation. So your hybrid inverter, breaking it down a little bit further, typically a string inverter. So when I say that, I mean that we're talking about how the modules are arrayed. So you've got a string of inverters wired in series, building up the voltages, running somewhere in the 200 to 550 volt range for most residential systems. It supplies AC to the grid just like a string inverter does. It takes DC from the array and or the battery. It determines where you've got the power at and what you need. It charges from the PV or the grid, and it could be and as well, so that it always tries to keep the battery charge level at a useful level to the best that it can. It isolates the system from the grid when the grid goes down. As you well know from string inverters, when the grid goes down, you've got to isolate yourself off so that you're not feeding power back. A hybrid inverter has kind of a unique situation here in that it's got to isolate itself from the grid, but still provide power for the critical load support. So you'll have your refrigerator and lights and so on and so forth that you want to maintain when the power is out. The hybrid inverter should handle all of that, and so you need to determine what it can do. Along those lines, it's not just handling it with the 5,000 watt inverter or 6,000 watt inverter, whatever it is, but you've also got to be able to support things like surge. When you start a motor up, it takes more power to get started, so your hybrid inverter needs to handle that. And then, of course, it doesn't need the grid to run. So if the grid drops down, your house still goes. It should be able to draw power from the PV array to supplement the batteries. If there's no PV, nighttime, it draws completely from the batteries. As the PV comes up, it determines what it needs, charges if it's available, supplies power if it's needed. Those are kind of the responsibilities of a hybrid inverter, and how it differs from a string inverter is, orders of magnitude different, because a string inverter is simply, is the grid there? Yes. Is there PV? Yes. Convert power and send it to the grid. Pretty simple compared to a hybrid inverter. It's also got, because we're taking power from a PV, you've got to manage your modules properly. That means you've got to have a maximum power point tracker built into your inverter. Ideally, these days, there's no reason not to have multiples. You should have at least 2 for most applications so that you can arrange your modules to take advantage of the roof lines that you've got, whether you've got shade to avoid, whether you've got roof planes to adapt to, whatever it is, you need multiple MPPTs to accomplish that with a string inverter. You've got to prioritize the grid, PV, and battery sources to satisfy the needs of the site. You want to make sure your PV is being utilized to the fullest. That's really the key point here. You don't want to leave power on the roof. You want to use it either in the battery, your loads, or the grid if that's available to you. So we talked a little bit in the past about grid support. When the battery is charged, and if it's allowed, AC is fed back to the grid. Exceptions to that could be Hawaii, Arizona, and Nevada, where there maybe not be any advantage to being able to feed back. Or if you can get time of use under those, you can save it and feed it back when it's a little bit to your advantage. You've got to be real careful with this. You need to check with your local utility providers. Some of them allow feeding back from batteries. Some of them restrict it as only being allowed to be charged from the PV system. You can't charge from the grid and then feed it back to the grid at a better time. You need to check with your local jurisdictions, your local utility companies, and find out what their restrictions are. It's really hard at this level nationwide to determine what your specific location requires. PG&E is different than Nevada Power, which is different than TXU. So you have to look locally to find out what's going on there. Anymore, you really need a hybrid inverter that you use to support time of use peak hours for feedback. So if you've got peak hours, they used to be at 1 o'clock to 6 o'clock, or whatever your local peak was. Now you need to look at it because they're changing because of solar being added. It's now 5 o'clock to 8 o'clock. So you need a hybrid inverter that's going to be charged and store the power until its peak and then feed it back at that point. 1, you'll get your better financial return, and 2, you're actually complementing the utility and helping them out. We need to work on this together. You've all heard of the infamous duck curve. If you can store your power during the day and feed it back during the neck of the duck, everybody benefits from that. But having said all that and feeding back, you've still got the requirement of any string or any inverter on the grid to isolate and protect the grid when it's unavailable. You can't feed power back. This is really important to understand that that does not change with a hybrid inverter. You do not feed power back to the grid when the grid's down. So we've been talking a lot about grid support, PV support. Now we're going to go into the critical load support. So when you've got a critical load panel, and this is your refrigerator, lights, communication devices, that is routers, televisions, radios, things like that, telephone chargers, all those need to be supported when the power is out for a significant period of time. You know, when your power is gone for 2 days because of the weather conditions, you would very much like to be able to support your lifestyle to continue on. So the critical load support passes through when the grid's there. So it takes power from the grid, supports and supplies power to the critical load path. So there's really, from the user perspective, no change in how power is provided for those critical loads. However, when the grid drops down, whether someone takes out a power pole, whatever happens, it must replace the grid quickly, usually within a few milliseconds. So you might get a blink of the lights, and that's all you'll see that it happened. So you need to make this transfer of power. It provides continuous power and extra surge for limited time when needed. So as we talked about earlier, when you're running on your critical load, you've got your refrigerator. The power needed to run the motor for the refrigerator at steady state is pretty low with the new energy efficient refrigerators. However, it still takes 2 to 3 times that power to get started. So you want to select and choose your hybrid inverter to make sure that on the critical load, it doesn't provide just 5,000 watts, but it can provide 6,000 watts or 7,000 watts or 8,000 watts or more for some period of time. Usually it doesn't need to be continuous, but it does need to be, you know, anywhere from 5 to 45 or 50 seconds to allow these surges to be managed. And then lastly, it needs to be easy to install. If it takes you hours to install a system, that dramatically affects your levelized cost of energy, your payback. It needs to be quick and easy to install so that you can get on with using it and get the installation going, done, and out of there. So included in this is also the BMS, the battery charge controller management system. So it's configurable for different batteries, whether you've got lithium ion, whether you've got lithium iron phosphate, whether you've got lead acid. You need a battery management system that can be either programmed or identify what it's got. And mostly it's going to be programmed at this point because the different batteries have dramatically different requirements for charging. It's got to, if it's a lead acid, which is the simpler system to use, it's got to have a charge current. That is a pretty beefy current to get the batteries charged back up when the power is available. And then in the interim time, in between the needs, you've got to have a separate charge system for maintenance charging. You know, keeping it at a level nice, topped off without overcharging and causing problems. For the various lithium chemistries, you've got to have, it's got to be programmable for voltage and current control. You've all seen the exciting news clips where, you know, people's phones, laptops, or hoverboards have exciting things happen when the charging isn't maintained properly, sometimes just in general usage. So the battery management system is what controls all that. So it's got to be programmable to support the chemistry that you're using. Be very aware of what your hybrid inverter can support. Most of them will be restricted to supporting just a limited number of chemistries. Lithium comes in many different flavors, so you've got to be able to, whatever batteries you're selecting, make sure it's suitable for the battery management system that you've decided on. Or vice versa, if you've selected your batteries, make sure your battery management system works with it. Then we come to batteries. We're not going to go into all the chemistries. There's just way too many of them. But these are the ones that currently lead the way for residential and very small commercial systems. Lithium ion and lithium iron phosphate can certainly support bigger ones, but our application for today is residential. Lead acid, typically used for backup rather than grid support or time of use support where it's a daily charge and discharge. I say typically because there are advanced lithium-ion chemistries now that do support that far better. Low energy density, that is, they don't store a lot of energy, and typically they are very heavy. If you've ever loaded up a 20 kilowatt hour battery box, you know what it's like. Your back feels it the next day. Typically, they've got a limited recharge count. That is, how many times can you drain it and charge it back up before they don't want to be drained and charged back up. You start losing capacity. Depth of discharge. Typically, lead-acid batteries don't like to go much further than about 50%, and most battery management systems will limit you by default to 50% depth of discharge. The one advantage is they're typically relatively inexpensive, readily available, extensive support for getting rid of the bad batteries. 99% of all lead-acid batteries are recycled. Every manufacturer has a recycling program. So it's really a nice, well-established, supported technology that's easy to deal with. The next one that I want to go through is lithium-ion. It can be used for backup. It can also be used for grid support because it has a relatively high count of recharge cycles. It's really good for that kind of thing. High energy density, so it can be wall mounted because you've got a lot of power in a relatively small package. It's light in weight. Easy to deal with as far as the mechanics. Good depth of discharge range. Instead of 50%, you can take them down to 75 or 80% without too much. That is good because you typically have a higher expense in buying them. They are getting less expensive, but right now they're much more expensive. If you can get a smaller size battery and discharge them fuller, you don't have to spend quite so much on the battery. They are sensitive to abuse. If you overcharge, if you let them discharge too far, if you charge too fast, if you have the wrong voltage, all of those can be painful, to say the least. Mechanically, they don't lend themselves well to abuse. If you put them in the garage and you run the wheelbarrow into them and hit them correctly, you shouldn't have it that exposed, but you get the general idea. Problems can arise from just a short circuit going through the case. The last thing is they're expensive, but they're getting far more cost effective. As volumes go up, prices are going down. Technologies are getting better to make the pricing better. So that's a good thing for the future and for right now. With a bigger depth of discharge, it brings the cost in line. Last one is lithium iron phosphate. It's great for backup, great for grid support. You've got good depth of discharge, good energy density, not quite as good as lithium ion, but still mid-sized and relatively light, so you can still work with it from a mechanical perspective. You can still work with it comfortably. A much better, excellent recharge count. Many of them can be recharged as many as 5,000 times. That's years of use, longer than lead acid or many lithium-ion standards. Stands up well to abuse. It's far less sensitive to voltage and current levels, far less sensitive to temperature extremes. Pretty much doesn't catch fire even under significant abuse. And again, just like lithium ion, expensive, but getting much more cost effective. As again, the demand goes up, the price goes down. So your early adopters are going to pay a little bit more, but they'll be able to take advantage, and they'll pave the way, just like PV did 10 years ago, for a lower cost ultimate solution. So now you really need a system, because we're going into the broad. This isn't the person up on the hill that wants to be separate. This is, tract homes in the suburbs that want this support. Just like PV, at first it was tough to install. There were limited standards. You were trying to figure it out as you went along. Now it's a simple, slap it in, put it on, make sure it's right, move on, because the technology is well advanced. You're looking for the same kind of thing as best we can with a hybrid system. You want something that's mostly pre-assembled. very fast install. You don't want to be out there wiring all the little control wires and communication wires, power wires, and all that. You want something that, if it's going to be floor mounted, you want it to be able to roll it in, level it, install the batteries, land the conductors. Now that's coming from PV, your AC grid tie, your critical load AC support, and the batteries. It should all be here. Most of these will not be shipped with batteries installed. Lead acid, way too heavy to ship that way, and lithium ion or lithium iron phosphate, they don't let you ship it under normal conditions installed. You've got to have a very controlled state of charge or depth of discharge. You've got to have it packaged separately. You've got to have it packaged uniquely so that only things of the same type, if you're going to ship it in a container, the only thing it can carry is that battery or batteries that are similar to it. So be prepared to have multiple packages. So you land the conductors, put it all together, and turn it on. It really should be as simple as that. There are some site considerations. Most of the country, all that is desired is backup right now. Lead acid is often adequate, especially the advanced lead acid chemistries. Load size is really important with lead acid batteries because they're big, they're heavy, lead energy density is not that great. So if you're in the New England area, you've got to be able to get power when the power goes down, power from the batteries when the power goes down. For backup, it only runs when the grid is unavailable. There's minimum recharge demands. So if your power only goes down 3 times a year, you're only going to be recharging it for those 3 times. Could be a few times for each one, but you're only going to be using it. And then limited usable capacity with lead acid. So if you're going to select this, make sure you understand that the depth of discharge is going to be limited. So you need to size it accordingly. For battery backup, lead acid, like I said, is usually pretty good. Just make sure it's big enough to handle it all, your expected downtime. Remember, you do have PV that can recharge it. Most situations that cause the power to go down are followed by calm air afterwards, where you've got the sun out, so you can recharge. So bear that in mind. You don't have to support it for 3 days just until the sun comes out. Site considerations for self-use. This is time of use power shifting. California is switching over to this. Hawaii has had it for a while now. Some places allow you to feedback, others don't. Your hybrid inverter, when you're selecting it, make sure you understand what your local utility requires, so that if they don't allow you to feedback like Hawaii, you've got to make sure you've got a PV system that handles what you can feedback, what you need to charge, and how you need to support your lifestyle during the day. And don't forget, you've still got the utility when you do run out of batteries. So you need to make sure that you can get through the night, you can get through whatever outages you may have, but then you've always got the utility to fall back on while you're charging your Tesla. So you should be able to handle that pretty well. California is moving time of use to off-peak hours, PV hours. So make sure that you can configure your inverter so that you can support that. You need to contact your local utility company, whether it's PG&E, whether it's San Diego or LA, to make sure that they're going to allow you to do this. But you need to have a hybrid inverter that can support it, because all of the utility companies are putting together policies to use it if they haven't already implemented it. So you want to be prepared to feed it back. Peak now is going to be mostly at nighttime, so that you can't use PV to feed back at peak hours. Limited return on investment with new PV installations, because you can't get maximum dollars back for your installation. You need enough storage to support the time of use power shifting. Now, what does that mean? You know, your typical peak is now going to be shorter hours, fewer of them, and starting late in the evening. So you need to get as much of the power that you produce during the day back out to the grid during peak hours. And then you've got to run after the peak hours. Typically, you want to recharge or support your local grid with battery support at night if you're trying to go off use, like in Hawaii and such. So bear that in mind. You need enough control over your feedback time to take care of that. in addition to leave time to recharge from the PV during the day. When you're using batteries like this, the daily recharge count is very important. This is why you're not using typically lead-acid batteries, because the recharge count is lower, at least on traditional lead-acid batteries. You're going to be looking at lithium iron phosphate is your best one for this because it's got a much higher recharge count. Lithium ion also works very well. You can use a slightly smaller battery as far as total capacity goes, again, because of the depth of discharge that's allowed with the lithium technology chemistries versus lead acid. So here's your last few, and this is Darfon solutions for these. So we've got essentially two full systems. Give you a category of systems. So the H100 uses the H5000 inverter. It's a 5,000 watt inverter of our own design. It handles overload capabilities of 5,500, 7,000, and 8,000 watts for the critical load centers. That's for 45 and 1 second periods of time. 6.5 kilowatts of PV is managed. 2 MPPTs, so you can utilize your PV effectively. We recommend, not included, but we recommend 8, 12, or 16 AGM Deca batteries. We're working on other lead-acid solutions right now. Mostly it's a problem of fitting within the cabinet. If you look back a little bit, you saw a nice cabinet with the batteries built in and all that. That's what the H100 looks like. It's about 5.5 feet tall. The batteries are fully self-contained inside. It allows you to literally roll it in, take a small area just a little bit bigger than a water heater, attach the wires, set the programming, and walk away. It's fully monitored, so you don't have to worry about that. The H200, very similar. It's got the same inverter, 5,000 watt inverter with overload capabilities, same 6.5 kilowatts of PV, same 2 MPPTs. The difference is the battery management system is preset for lithium iron phosphate. You can order it with anything from 2.5 to 15 kilowatt hours of batteries, and both of these can be installed very shortly with the ability to put up to 3 of these units together. So you can have 15,000 watts of power to support your house, or up to 45 kilowatt hours of lithium iron phosphate batteries to support the house should you have a pretty high load. This is a nice, very simple, roll it in, hook up the wires, walk away type installation. Very fast. We also provide the H5000 as a separate standalone unit. It's wall mounted. You can define your batteries, your housing. It's the same hybrid inverter as the 200 and 100 use. So a 5,000 watt inverter, 6,500 watts of PV, and so on and so forth. We do provide, most string inverters, that 5,000 watts of output is kind of correlated to how many watts of PV you can have. But remember, with a hybrid inverter, you're doing multiple things. You're not only feeding back to the grid, but you're also potentially charging the batteries or providing power for the house under certain conditions. So you really need to look at both sides, not only how much PV you can attach, but also how much power you can support. And that's where the 5,000 is a really nice unit. So now the bottom line, how do you select a system? First of all, you have to find out what your customers want. First and foremost, every customer that I've talked to, the same thing. They want to save money. I mean, not every one of them care, but it's consistent enough that you have to be aware of that. Can we still save money with an energy storage system? Yes, but it may depend on where you live. Easy in Hawaii, easy in California, easy in some of the New England states where the cost of electricity is high. But if you're in Texas and they're giving away free power because the wind support is so high, that's going to be really hard to save money. Security. Can I power my home from my PV system when the grid goes down? How many of you sat in the kitchen across the kitchen table from your customer when you tell them, no, when the grid goes down, your PV system has to shut off? Well, that's no longer the case. Now you can put in a system and say, no, when the system goes down, when the grid utility system goes down, your PV and your batteries can still be used to run your household. That's a really big, powerful statement to be said. It can now be done cost effectively. Independence. These are the other things the customer wants. Can I remove my house from the grid? Yes. Well, maybe. A modern tract home is really not designed to be off-grid, so there may be other changes that you need to deal with as far as efficiency goes. Should be done before you install PV for any house, but even more so for a hybrid system with battery support. It really dramatically affects the cost of entry if you have to support inefficient designs, a huge home, multiple refrigerators, multiple air conditioners, or whatever you've got. So when you say you can remove your house from the grid, yeah, well, maybe. It depends on your house and your lifestyle. That's it, Kathy.
Thanks, Brian. That was excellent. Very interesting presentation. I learned a lot, and you did a really great job. We appreciate that. And we do have some questions coming in, so we'll ask those.
Great.
There's still time to submit questions, so feel free to send one in now if you haven't already. And hopefully that little break was enough to let you have a sip of water there, Brian. But
yes, it was. Thank you.
Okay.
Hope it wasn't obvious.
No, not at all. I just know that's a lot of talking for a presentation. I want to give you a moment. But, okay, someone's asking if you could maybe go over the differences between a hybrid inverter and a traditional string inverter again. Is a smart inverter also necessarily hybrid, or can you go over that again?
Excellent question. Yeah, I have no problem with that. So a hybrid and a smart inverter are different, at least in the traditional context of those terms. A smart inverter understands the grid and provides power according to what the utility wants. So that could be reactive power support. It could be turn on and turn off based upon what the utility company is telling it to do. Not necessarily support of the house side, your side of the meter control. So in other words, a hybrid inverter will control the PV, will control the battery, will control the loads, but it won't necessarily control the feedback based upon what the utility company wants. Smart will not necessarily support PV, battery, and loads, but it is allowed to be controlled by the utility company. So they can turn it off or turn it on, usually as an aggregate of the inverter company. At least that's all that I have been seeing recently. So the utility companies are going to want the DARFONs, the SMAs, the other utility companies to provide an aggregate of power for areas, and that they can have a simple control to turn off the inverters or turn them down as needed. That's not required anywhere that I know of as of yet. It will be coming in a few years, so we're all preparing for it. For a hybrid inverter, again, you need to be able to control PV, control batteries, control your loads, whether that's the load is the utility grid, feeding back power, or whether that load is your critical load center with your lights and your refrigerator and whatever else that you deem necessary. So that's really the difference between a hybrid and a smart. It's two sides of the same thing, or a similar thing, I should say.
So you don't necessarily have to have a hybrid inverter with an installation with storage. There just might be more work involved from the utility side, or from the manufacturer side. You just have smart.
If you've got storage, you don't need a hybrid inverter, but you can build. You're going to go to the old way of a battery supporting inverter that has your own charge controllers, and you're going to fill up the wall with a bunch of equipment. A hybrid inverter is taking all of that. That very first slide that I had that showed a stack of lead acid batteries and a bunch of boxes on a wall. That's the old style. A hybrid inverter takes all of those hardware pieces that are mounted on the wall and combines it into a single simple box that controls everything. That's a hybrid. These days, if you're looking for battery support, I would look at a good quality hybrid inverter simply because you can install it in the same amount of time, roughly, that you do a standard string inverter. With a string inverter, you're going to have a set of wires from each of the strings that you've got from the PV, and you're going to have 4 wires, 3 or 4 wires going to the grid. To install a hybrid inverter, a modern hybrid inverter, you're going to have the same wires for the PV strings, the same grid tie wires. You're going to add another set of wires to go to your critical load. That's the only change in a hybrid inverter from a string inverter for installation. So it really is, whereas with the old style, you spent hours, days even, depending on the size of the system, putting all the components together, wiring them up, stringing them up, making sure they work, programming them correctly. It could take days to install some of those larger discrete systems.
Got it. Thank you so much, Brian.
Yeah.
A couple more coming in here. Does the battery management system or the charge controller is that usually provided by the inverter manufacturer, or is it a separate component, or where do you usually buy that piece of equipment from?
That's usually from the inverter manufacturer. At least that's always been for me. They will provide that because they need to understand what the chemistry requires for charging. So that the BMS has to be able to communicate to the batteries, and it has to be able to communicate to the inverter. So there's a very close tie between the BMS and the inverter. So usually the inverter company just takes on that responsibility of providing that. And then they'll make recommendations on batteries. If you look back do you mind if I back up a slide or two here?
Yeah, go for it.
So if you're looking back at this one where we've got the H100 and the H200, we're making very specific recommendations on batteries. With the lithium ion, we're providing them. We're providing the BMS. Why? It guarantees that the installer and the homeowner is getting a system that is tested, proven, and the battery management system works with the batteries and the charging inverter so that there's no risk of bad things happening. With the lead-acid systems, battery management is much simpler, but now we need batteries that we know we can support with our charge circuitry. We know that requires a minimum of support as far as, you shouldn't have to, these days you should never have to deal with, specific density and water levels and stuff, and that it fits inside the cabinet. When I say inside the cabinet, 1, 2, 3. This is our H100, H200. It's a little different now. This has the old front plate on it. We don't have that anymore. It's a much more streamlined plate. Looks much better. But other than that, it's exactly the same size. This is about 5 foot 8 inches tall and about the size of a water heater. So very easy to install. This has the lithium iron phosphate battery showing. This is the H200. The big white connector in the right-hand side of the big faceplate, that's for generator support. I really didn't talk about that today, but you can control 2 or 3 wire generator support to have it automatically turn on and take over the house if you need to. But the battery management system usually comes with the inverter and is very specific to the chemistry that you're using.
Awesome. A lot of people are asking about selecting different battery types for different environmental considerations. So, someone was asking how you go about looking at battery options in relation to the environment, like how that impacts battery selection. And then one person specifically named, is there a battery that lends itself to quick recharge in like really cold weather? So how does environment and weather factor into battery type selection?
Actually, the battery selection, the batteries we've chosen are the ones that we've worked with. The BMS for our system is completely programmable. Understand that with what we sell, I'm only going to use what we sell because I'm not going to speak for another manufacturer. So ours is completely programmable. So as long as you know the charge rates, the voltages, the current levels that you want, you can get in, program the BMS to support whatever you want to put in there. So yeah, you can select your own batteries if you want to do. I can't imagine doing it, but a flooded battery, that's a big water battery, you could do that. If you, unfortunately, aqueous energy has gone away, at least temporarily. that would be very easy to program, and that's probably the one that I would recommend for cold weather, unfortunately. Lithium-ion and lead-acid batteries work best when you're comfortable. So if the temperatures that you're at are comfortable, that's what the lithium-ion or the lead-acid battery likes. That's a real easy way to determine it. You start getting really cold weather, you lose potential storage capacity, you lose voltage, you lose a lot of things. All of our battery systems, the H100 and H200, are intended for installation in reasonably well-protected environments. For a garage, would be fine. If you're in, Minnesota or North Dakota, you'll probably want to keep it up near freezing or better. But you can certainly program the BMS to support any battery you want as far as chemistries for really cold weather, and I mean cold weather. I just don't know of any that at this point in time work well in really frigid weather.
Great. Okay. Well, I think that's all the questions that we have time for right now. But if we didn't get to your questions or you have additional ones, feel free to contact Brian on your own. But I just want to say, thank you again, Brian. I really appreciate the great presentation. You did a great job. We really appreciate you being here.
Thank you. Thank you very much. I enjoyed it.
Great. And just a reminder, this webinar will be emailed to all registrants, so you can view it at your convenience. And thank you to our audience for listening. We invite you to join us for more Solar Power World webinars. We'll be discussing how PV systems can help stabilize and secure utility grids on April 27th, and then how to use solar financing to grow your business on May 2nd. So make sure you're registered for those upcoming ones. But we'll see you back here. Thank you so much, everyone.